All right, it says we're live. Welcome to the show, everybody. Today we're going to talk a little bit about antennas and transmission lines. And I decided to ask two of my buddies who are experts in the field of antennas and transmission lines. Chuck, KK6USY. Say howdy, Chuck.
Where are those guys at? Oh, hey, howdy. I guess I know a little bit about antennas. I make a few, but yeah, I'll tell you what. My video, I did that video and I asked for comments on should hams make antennas. I must have got 50 comments
strange
already.
Ones as always, right?
No strange ones. Everybody was in agreement that hams should make only two guys. And one of them, I think, was just sticking up for people that maybe had problems where they couldn't actually maybe do the work. It wasn't like
outliers. Sure.
No, you shouldn't. Yeah, it was okay. I'm going to do a video on that one though. I'm not going to say his name, but I got something planned for that if I can make it work.
And then I got my buddy Ziggy, the 75 ohm ham. What's happening,
everybody?
Ziggy?
Oh man, I've been having a blast out in the field lately. We just closed on our antenna challenge, and Paul won it. And the great thing about Paul's antenna submission was not only did he hand make his own ladder line out of copper tape, he strung this thing up inside of his living room, and all that data that he showed was from this antenna HFing in his living room.
His house.
Yeah,
He's a creative
inside
guy.
the house. Inside the house. I totally missed that the first time. I was like, I heard him
He's
talking about
saying-
his house orientation.
Well, Prep Ham Paul's in the chat, and he's saying it's the other Paul, not him, Paul.
Yeah, it's the other Paul, not him, Paul.
That's the other Paul. Okay.
Yeah. Hey, Bill in Alaska. How you doing?
I missed
And hey,
I
Jeff,
missed the
hey,
beginning
45.
of that, so I didn't see all.
I am a
need to go
dumbass
back and look
because
at it.
I thought that this thing was ending January 15th, not December 15th.
And that was my fault.
So, well, but you were telling me, you're like, hey, have you gotten started on that antenna? And I'm like, yeah, because I'm thinking I got plenty of time to do it. So I was a little late behind the curve there.
He was sending me progress pictures, and
you know
I was
what
like, "Come on."
He
You
said
need
he
more
goes.
progress than that.
I told him I'm editing a video, and he goes, "Oh, the one for the contest." I'm like, "No, that's not until when is it?" I go, "When is that?" And he goes, "Tonight." I'm like, "Shh." So
I got really excited.
I built mine in like I had like 2 hours before he came on the stream, and I was tuning it as he was talking.
Yeah, so we have a lot
I'm
of
gonna
ground to
prove it
cover
now.
tonight, and I forgot the clubhouse is on later, and I don't want to step on those boys too much. So that said, the first thing I want to do is I'm going to play an ad from our sponsor. Unlock the full potential of your electronics project with PCBWay.com. Enjoy high-quality PCB manufacturing and assembly services that fit your budget and timeline. Experience swift turnaround times, dependable worldwide shipping, and the peace of mind that comes from working with industry experts. From fine-tuning prototypes to scaling full production, PCBWay.com provides the reliability, value, and support you need. Visit PCBWay.com today and turn your vision into reality. All right, now that that's done, we'll go ahead and we'll jump into it. Now, as always, I put some slides together. The first one we got here is about the importance of antennas and ham radios. I'm just going to talk about I got my notes here because I'm a consummate professional. And so what I wanted to say is that antennas play a foundational role in ham radio operations. Think of the antenna as the voice of your station, where even the best transceivers falter without an efficient antenna setup. Investing in your antenna system often provides greater impact on overall performance than amplifiers or upgrades. In this slide, we're exploring the importance of this component and its unmatched value in enhancing signal strength and clarity. And a lot of people say that your antenna should cost X amount of times more than your radio, and I don't necessarily know if I subscribe to that.
Doesn't
Are we
have
getting
to.
married to this thing? Like, is it 3 months salary? What are we talking about?
Right. Well, I think it goes back to if you buy antennas, you're definitely going to pay a lot of money for them, right? And then
Right.
especially with your transmission line and stuff like that. Now, I do buy my transmission line. I don't make open feeder or balance line or anything like that. But if you build your own antennas, it can cost significantly less than 3 times the cost of your radio. What you guys think about that?
I think it's true. I mean, it depends on what kind of antenna you're building. If you're building a Yagi and you got to go out and buy aluminum, sometimes you're better off just to buy an antenna. already, set up and to put it together.
Well, like a
If you-
big,
if-
like your Mosley or
Like a
something
big,
like that.
like a Mosley or something like that. Because there's a lot of my Mosley's even different because it's a tri-bender, so it has coils. So you'd have to make the coils, which you can do. But all that stuff, when you have to buy aluminum, metal's expensive when you start buying aluminum. Now, if you're making wire antennas, you can probably save quite a bit of money on those, I think. What do you think?
Yeah,
Sid?
all my antennas are wire antennas. Zig, what about you? You buying antennas? You building them?
I'm trying to think. There's got to be okay. So I've purchased a GP1 in my entire lifetime. There's one, but that was kind of like a clubhouse expense because that's
I
part
have a
of my.
GP1.
I
You
thought you
talking
had
about the
a.
2 meter 70 centimeter Comet?
I thought you had a 3 or a 5 or a 7 or something.
I have
thought
the
you had,
SBB5 on my car,
Oh, that's what it was.
or my Jeep, I should say.
And I said something colorful about my Comet GP1, and you said, "Are we talking about the GP1?" I just had to change my frequency on my node again because it got longer again. So now it went from 147 megahertz. It's now down to 144.5 megahertz. So I just had to update the transmit frequency on my node to get more efficient. I don't know why it's getting longer.
Well, that happens to you, right? All right. Well, let's keep.
let me give you a little example though. You were talking about this. So my Mosley right now, if it's a TA33, if you bought it, it's $815. I paid $150 because I bought mine used. So if you guys keep your eyes open, look at the used stuff. Maybe you can find.
Don't
something
you
like
have
that.
two of them? Don't you have one in the box?
Well, I actually did buy two. And I think I spent $150. I got those two. I mean, I looked like a guy that was collecting aluminum when I got home. There was, I got a picture of it someplace. And so if you can find them used, sometimes you can get a good deal. Unlike this guy, this guy had passed away, Silent Key, and his wife was a ham also. And she decided she didn't want to do it anymore. So, and I got it off of we have a ham net that does they don't sell anything, but they list stuff for people. And that's how I found it. I drove about, and fuel was a little bit cheaper then. I drove about an hour and a half each way, about 3 hours to go pick it up.
Yeah, that costs you some money these days.
And they just kept stuck. Here, take this. Here, take this. They were just trying to get rid of it. I should have just stuck around a little longer because they didn't want any more money. They just wanted to get rid of it. So
I'm not.
Yeah,
gonna,
but
so that's
that's
the
a
way.
heck of a
That's the way
deal.
to save money. That's the way to save money, and that thing works. I think I put $100 in it to replace a couple of the parts for it to smell bad.
So
What are
this
we
is
looking
Testing it.
this is somebody's product, and this is the second antenna that I've ever purchased. Okay. And but anyway, I only purchased this because the screw holes were potted and the lid was super glued or hermetically sealed, however they did it. That's
So
pretty
hoping
much
it
the only
levels
reason
up.
why I bought it. And this wasn't cheap. This was like $80-$90. And I opened it up and I was like, oh, it's exactly what I thought was going to be in there.
Was it 49-1?
91.
9-1.
I just, it was kind of more of a like an R&D purchase because I just wanted to see what the other manufacturers were, how they were building their stuff.
Yeah, they're always fun to crack them open and see what's going in there.
Mm-hmm.
I was
Yeah. see what's not right sometimes.
There we go.
I was not thrilled. I was a little bitter, but you know, what was I expecting?
Hey, bass angler. All right, so we'll keep on trucking
That's
here.
That's bass angler.
So I have some basic antenna concepts, and I have antennas are intricately tied to their operating frequencies, making resonance a key principle in efficiency energy transfer. By tuning dimensions to match wavelengths, energy loss is minimized. Radiation patterns, both azimuth and elevation, reveal how signals radiate. Influenced by height and surrounding. Lastly, polarization matters. Vertical antennas suit mobile applications, while horizontal ones may excel in certain bands. To some extent, we'll explore each one of these concepts. So, Chuck, you always do a good job talking about polarization and loss, and I think you typically talk about it on 6 meters. Can you help us out there?
Yeah, 6 meters. Once you go a certain distance, sometimes it really doesn't matter. You could talk from a horizontal to a vertical.
Mm-hmm.
But like when I was doing CB around here, I had some really good like Yagis, and around here, local, everybody else was vertical, and my vertical killed my 4-element Yagi. But for distance, different story. But sometimes with CB, like it's kind of like 6 meters when it's open, you can talk on anything. But polarization,
Well,
though,
if you're
for
doing
most
if you're
people,
doing skywave propagation, it doesn't matter, right? Because everything
right,
gets jumbled
right,
around up in the ionosphere anyway.
right.
It's really more about line of sight.
And 6 meters, kind of that kind of line of sight, but it can go when it opens, man. I got in this, South Carolina last year.
Yeah, well,
When
that
it
ain't line
opened
of
up.
sight.
No, but that was 5 elements and a good band opening. That was my up to that point. Tennessee was my farthest contact, and the guy in Tennessee his name is Howard, and that's all he does is I think it was 2 meter and 6 meter. But he
Well,
but
what
he
is
might have
it
been
like?
doing most of the carrying. Even though I have 5 elements, he had like I think he had stacked 6
Well,
elements or something.
if you're doing line of sight and you go both are vertical and then one goes to horizontal, it's like a 9 dB loss, isn't it?
It's quite a bit. Now, the owner of M Squared Antennas his name is Chuck. Chuck, yeah. And he told me when I was talking one day, I was like, "Well, this is 5 watts," and he goes, "I can hear your 5 watts in Fresno." I was on like a 10 or 11 element 2 meter, and Fresno is about 150, 160 miles from me. But what he did tell me is that one had it when you set the whole thing up, it had both vertical and horizontal. He said if you take that horizontal and turn it at a 45, it's only like maybe a 2 dB loss each way. And he says it'll do just fine like that. So, but if you're talking 6 meter to 6 meter, if the other guy is vertical and you're vertical, it probably works pretty good for short distance silent line of sight.
You've seen those triangle beams, right? And they call their horizontal elements are actually the two, whatever angle this is. The two 45s at the bottom.
Right.
That's actually the horizontal element on there, and that just makes my head itch. Like,
Well, that's like the quad antennas, like these.
You don't want an itchy head.
If
You might
if it's loaded here, it's one
shave off
thing.
all your
If
hair.
it's loaded there, it's another, right?
Well, that's like a circular pattern, right? And Hillbilly Ham is telling us he thought it was 20 dB loss, and that might be true. I just don't remember.
I don't remember either, but
That's in a perfect, pencil and paper kind
Right.
of thing.
And old Kevin is saying that he could stand to lose about 30 pounds.
I could too, Kevin. My bike would love
What's
that.
happening, Mike?
My
How you doing
motorcycle.
today, buddy?
Hey,
Michael.
Well, I want to talk a little bit about resonance. And a lot of people are like, I only use resonant antennas. And an antenna is really only resonant on a single particular frequency. Now, sometimes
Right.
you get the benefit of harmonically related frequencies being near or close to resonant. But if you have an antenna that's resonant across the band, then you probably have a problem with loss. And resonance is really when there is no reactive component. And we're saying this is a beginner's thing. If you're really interested in impedance and resonance, I've got a couple of videos on that where I go into detail. But when you change frequencies, the resonance is heavily frequency dependent. And as you change frequencies, the circuit behaves differently, the circuit being your antenna. And it introduces elements of reactance. It's either capacitive or inductive. If you have any reactance, then you're not resonant. Resonance is the absence of that. So a lot of times you can have an antenna that's 2-to-1, 3-to-1, 4-to-1, whatever, and it's resonant because it doesn't have any reactance to it. A good example is a dipole at half wavelength above ground is 75 ohms impedance, but that's considered resonant at that point. So,
Well, your best
And-
SWR, like on a dipole, may not be the most resonant part of your antenna.
well, they say that a lot of people actually mess their dipoles up when they trim them to get them to be 50 ohms impedance, because the way that you're in areas of high current on your antenna is where you have the strongest radiation coming off of your antenna. You really need a full wave of current on your wire or your aluminum, whatever it is that you're using, if you want to get maximum radiation from your antenna. So when we start playing tricks like adding coils and traps and loading antennas and stuff like that, you're shorting them and you don't have that full wavelength on there. So you might have a clean match, but you certainly you're actually losing some of the power that's going into your antenna as ohmic heat and not as radiation resistance, which is what you want.
Does
So it
nano
can be
VNA
problematic.
show X?
It does.
Oh yeah.
Because when you get X as close to 0 as possible, that's where your antenna is actually resonant at.
Yeah, when X is zero, when it's zero. So Chuck's
Or
talking
as
about
close as you can get.
the formula for impedance is Z equals R resistance plus X reactance. And you want it to be purely resistive at 50 ohms, which is almost never, ever the case. So good luck to everybody who only uses resonant antennas, I guess is my point there.
They work.
Yeah. So, common antenna types for amateur radio. So I have different antenna types cater to various needs and constraints in ham radio. Dipoles are popular for their simplicity and versatility, and I really like dipole antennas. They work well across multiple bands. Verticals are favored for their space-limited setups, offering good DX performance because of low takeoff angles. We'll talk all about that in a minute. Yagi antennas bring directional advantages, amplifying signals when reducing interference. Finally, loops and end-fed wires are great stealth installations, and that's what I mostly use here, end-feds, because I don't have to worry about my HOA getting all worried about it. They balance performance and discretion. Each option has unique strengths suited for specific operating scenarios. Hey, Andy. So what do you think, boys? You want to talk about takeoff angle first?
Yes. I saw something pretty awesome today. You typically think of a quarter wave coil loaded, base coil loaded antenna. So for instance, I saw recently the ATOS is a topic. Anyway, it's a base loaded quarter wave vertical, I think. Most of the current, what is this term? It was current feet or something. I think it was amperage feet, amp feet is what it was called. So you have the highest current right as right at the base, right?
And then you put a coil on top of it and choke it out.
And then you smash it with a coil. So therein lies a problem because we're smashing all that high current. Now enter the mid coil antenna. It preserves all that high current feet at the base before we get to the high voltage part, which I think is the smarter way to do it.
Well, you still incur losses there, and there's a pretty big debate around which loss is better, middle or center loaded or base loaded. The actual best is to use a capacitance hat at the top of any shortened vertical antenna, because that way you get maximum current for the longest stretch of your antenna by putting it right on the top. People say, hey, well, I love my ATOS because it tunes easy and I can make all these contacts on it. It is significantly compromised antenna. Now, I'll go on record saying if I had to pick which antenna to use, a ATOS or a ham stick, I would choose the ATOS every day. But we use the ATOS for simplicity and convenience. We don't use it because it's a superior antenna. And I know that upsets people, but it's the truth.
Well, anytime you got to use a coil, you're gonna take some of it away, right?
100%. But the thing is that with ATOSs are great, but when you're talking about an 8-foot antenna on 40 meters, you're really, really digging yourself out of a hole there. Ham radio, John, what's up? See you later.
They're cool because if you do own a Yaesu radio, and most of the radios will work with that antenna, they will tune real easy for you. So that makes it easy, especially if you do want to go down the road with some HF. I've done HF. I went with a high Q antenna, but the difference in the high Q is it's about this big around compared to this, to that. So less coil. It doesn't move. It doesn't grow like most of your screwdriver antennas that grow as you and shrink as you tune, right?
With that Tar Heel, the Tar Heel's the one that grows, right?
The Tar Heel's the same way. It grows. Mine's all internal. It has something that moves inside, so it's a little different than all the other ones, and that's one reason I went with it.
It's probably just the jumper on the coil, right?
Yeah, it's all motorized, so it's.
Well, I'll tell you what, old Ziggy
jumper.
got some ants in his pants. He
can't sit still.
No, he's a fidgety type feller. I tell you that right now. But I think
he's on the freeway.
He's on duty right now. What's that?
If you're going on the freeway, hamstick will work just fine. If you want to talk
hamstick. I'm not a.
They work.
I'm not.
They work.
I don't have the attention span to do HF in the car. I know a lot of folks will use the ATOS with the 891 and do POTA from the car, which I think is
Mm-hmm.
a great solution for that.
Yeah, especially if it's nasty weather, right?
Yeah,
You can
yeah,
sit
for
inside.
sure.
Same with mine. You can sit inside. I've got mine set up. I got 300-400 watts I can throw to it if I want to.
All
Mine
right,
will
so
take mine will take legal limit,
all right, now
which I don't have.
I'm going to talk a little bit about antenna gain and directivity.
Ooh.
So what I have is antenna gain and directivity are critical parameters for influencing ham radio performance. Gain reflects how well an antenna concentrates its energy. So it concentrates energy from a transmit perspective, but it also concentrates signals that it receives. So they work bidirectionally for transmitting and receiving. We typically measure antennas against an isotropic radiator, and when we do that, the measurement is in dBi, or a dipole, which is dBd, which is their standards. Directional antennas like Yagi's excel at enhancing signal strength towards specific targets while diminishing interference from other directions, like front to back ratios. So I'm going to ask Chuck to talk about that because he does such a great job. However, this focus comes at the expense of broader coverage, requiring careful planning to balance the range and utility. So you actually, before we get you talking about Yagi's and front to back ratios and gain, talk about that antenna that you're building. You were just flashing it. I'm gonna put you on the big screen and how
Oh,
that's going to work out for you.
so this is I'm revisiting my cubicle quad, and if you notice the difference in this one, it has a square boom, which before it wanted to turn all the time, and I did it on these before, and they were hard. You can't really screw into those. You can, but there's not much to screw into. But it also has, get my hand out of the way.
And you designed all this when your 3D printer, right?
Yeah, it took me like about half an hour one day to, I designed it on
Thank you, Regine.
on a CAD system, but and I'm not the greatest at it, but I just redid it today so that at the ends of them, so I can actually poke these through the ends now, like that, and I tighten them up a little bit, so that way I can use a longer one and adjust it. So it doesn't have to be super tight, but see, as you can see, it's not right now because it's not as square as it should be.
I got to tell you, man, you're like the premier antenna builder on YouTube. Fantastic job.
I just love building antennas, man.
So
And
tell us about front to back
I want
ratio and your Yagi.
So front to back. So what happens is your Yagi has it's not all of them, but most of them have a reflector, a driven, and a director, right? So let's just talk three. So what happens is all your energy is it bounces off that reflector and goes forward in the director, and all that gives you gain. So your angle, the more, if this makes sense, the more elements you have, the tighter your angle gets, right?
Mm-hmm.
And if you're not going too far, that means you have to be more on the person. But 3 elements across the country, I just hold mine at Northeast, and it's pretty much all of the East Coast. So by directing and hearing, it's actually hearing too. Now you're rejecting off each side and rejecting off the back. Not
Signal
saying
to
you won't
noise
hear
ratio,
somebody.
right?
Yeah,
So, I mean,
I'm not
it
saying
really
you won't
helps
hear
with that.
people, but you'll hear more forward than you will hear from the back, right? And I've had guys. I was on 6 one time, and some guy blasted in on my little 6-meter Yagi, and he was close. He was super loud though, and he was off the back. You'll hear guys talk when you're listening. Oh, I got you off the back. Like I was listening to a guy from New Zealand off the back of my antenna one night, and I turned it around, and it went from like he was like S2, S3 to S9, right?
That's crazy.
When you dial them in, once you get used to a Yagi, it's like dipoles are good for the big bands, for the low bands, because that's why I'm building that phased antenna for 40, so I can get some directivity, and it's my lot's actually pointed the right direction for me, so that's good.
Yeah.
Just run
So
down
we
the side
got
a lot.
Wiley Trailer is asking a question. He says, why do the discussion and drawings of a dipole indicate maximum current and minimum voltage occurs at the feed point? Isn't that also frequency and line length dependent? It's dependent upon where you feed your antenna. And if you think about Ohm's law, it'll make a lot of sense. So when you feed a dipole in the center, you're going to have around a 50 to 75 ohm impedance dependent upon the height above ground if you do things correctly. If you feed a dipole at the end, like an end-fed half-wave dipole, a lot of people call them end-fed half-wave. It's the real name of the antenna is an end-fed half-wave dipole. You're feeding at the end, and your impedance there is around 2,450 ohms. If you feed it in the center, off center, like an off center fed dipole, you're looking at around 250 to 400 ohms, depending upon where you feed it. So it's really about where that wave, earlier we were talking about like a full sine wave on the length of your antenna. It's really about where the frequency of the wave that you're transmitting is from a current standpoint on the length of that antenna. When you feed it in the center, you're going to have higher current and lower voltage. At the end, you have lower current and higher voltage because the voltage builds up towards the end of the antenna. Voltage increases, current goes down. And you also have higher impedance there, which drives all that based off of Ohm's law. Hopefully that answers your question.
Answered it for me, man.
I don't even know what slide.
Don't forget Richie.
I got him. Richie, thank you, buddy.
Oh, you got him?
Yeah, I got him earlier. Thank you. I appreciate it.
Oh, okay. I missed that. Sorry.
Let's see what we have here. DIY Electronic Experiments is asking, have we used multi-element antenna phased arrays? I haven't. Chuck is working on some phased array project with John Gendron.
I've played with some just like a regular Yagi where one's where they're not hooked together. Just what do you call that? Lost the word there. Sorry. It'd be like a regular Yagi on the ground, but I am going to do one that's hooked to where I can switch it two directions. And I'll tell you the truth, most of the time it's going to be shot east, northeast, but I will be able to switch it to go
back and forth,
southwest. I think. Yeah.
Yeah.
And I'll do when I finally get it set up, I'll do some testing on it and show you the difference from. And then I'll show you some front to back.
Thank you, Starman. Much appreciated.
Thanks, Starman.
Hey, thanks, man.
All right, let me get back here, and we're going to talk about the types of transmission lines. This is Ziggy's area of expertise. So I have transmission lines are vital conduits for signal delivery between transmitter and antenna. Coaxial cables are the most common, balancing ease of use with performance. Ladder lines excel in efficiency, particularly for HF. But you have to handle ladder line very carefully. Ladder line uses what's called air dielectric, as opposed to coaxial cable has a foam or a PTFE dielectric. You can see that in the picture. That's that white center. When you use that air dielectric, ladder line, window line, all that stuff becomes very sensitive to dirt, grime, water, cobwebs. Anything that can get into that air gap will create a dielectric and adjust your impedance and cause potential SWR issues.
The problem I have is rain with mine. I use 300 ohm, which is a little more susceptible to it than the bigger stuff. But
it's a nice gamble, right? When it's raining and there's nothing else to do besides play radio, it's like, let's see where it wants to be.
right. But it
Get
works
the dice
great.
out.
I have hardline cables are favored in high frequency applications where even small losses matter. Each type has distinctive trade-offs and depend upon your operating needs. So coaxial cable has loss. All of it does. Some of it is designed to be close to lossless or low loss in HF frequency, but almost all of it incurs loss as frequency goes up. So a lot of times the same coaxial cable that you use to talk on the HF bands is not what you want to use for your 70 meter antenna, because you're going to incur significant losses. Sometimes those losses can be 80-90%. So we typically would use like a 50 ohm coaxial cable, but my friend Ziggy down here, the 75 ohm ham, insists on using 75 ohm cable for some reason.
Thank you, Big John's Ham Shack.
Hey, Big John, how you doing, buddy?
He gave me that big old spool.
Oh, okay. Well, thank you, Big John, for the big old spool. Yeah. But why don't you talk a little bit about some of the experimentation that you've done with the 75 ohm cable and all the fun that you're having with it?
All right. When I was a young ham, I didn't have 50 ohm coax, and my field is like 250 feet that way. And then not only that, where my shack is great, right? Because the power line drop is right on the other side of the wall. So anything I put out there, I'm listening to the whole neighborhood through, coupling or whatever. But I had a CB buddy. He came by. He dropped off a big old box of nice TV coax, and he said, "Just hook it up, man. Life's too short." And I did, and I was so glad I did, because I didn't understand why we weren't using this. And what happened was I just happened to fall into whatever harmonic for my 80-meter infed half wave. It was so great and so close and such a wonderful, my wife told me to say it right this time, a happy little accident. And Ape actually turned me on to Sim NEC software. And if you don't own that software, you need to go find it and download it right now.
It's free.
It's great. I sit there and play with it all day if you let me. I finally gotten down to the brass tacks of what it is that I accidentally am doing here, and you can just tune your 75 ohm feed line for the harmonics for the amateur radio bands of interest, and I can show that if you want me to. I've got a quick little live demo.
Do it, man.
Yeah, let's do it. Let's share a screen. Which screen? The entire
TV's
screen.
cutting edge, man.
I'm trying to keep it up to date for you fellas. All right, so the cable I've got here is got a 0.87 or 87% velocity factor. And now how I'm tricking this software is I'm saying I have a 50 ohm matched antenna, and I have a 50 ohm transmitter, and then here's my transmission line, and I've told it that it is 75 ohms. We're not going to worry about the capacitance of that. That is way too out of the ballpark right now. So what do we got here? We got some harmonics off to the right. You see this, guys? So this is 121 feet, and those are the bands. And that's pretty much right where I wanted to be. I can't like zoom in because this is software and I'm sharing a screen. But as you can see, the harmonics for 20 meters fall here, and for 15 meters, oh, sorry, wrong screen, 15 meters, looks like you can do 12, not too bad, and right where you want to be on 10. And this is with some TV coax, guys, and it's just 121 feet of it. Now you go playing with the length, you can move this around. Let's make this feeder short, right? Let's say I only want, I gotta be shorter than that. Next harmonic down. So here we go. We are at 60 feet. 60 feet, and we have a harmonic at where you want to be at 10 meters, another harmonic at 15, and your another harmonic. And meanwhile, remember what's happening here is that we're using the feed line as a transformer, an impedance transformer.
Yep.
Now, if your antenna is a perfect 50 ohm and you want to use 75 ohm coax, this is what you do. You would trim it to 60 feet, and it would fall to 50 ohms at the antenna side. If you have a dipole, what do you want to do for a dipole? You want to give that dipole a 75 ohm or 72 ohm impedance. So what do? We make it longer? Let's make it longer. So now, that's not good. Let's go one more harmonic.
While you're doing that, our friend
go
the Hillbilly Ham's asking what the software is. It's called Sim NEC. And I think I've got 2 or 3 videos on using it. At first, you're going to be like, what in the world? Because it's not easy.
It's pretty intimidating.
So you're going to need some help getting off the ground with it, but once you start using it, you'll be fine. Sim NEC. Some folks will call it Sim Smith, which was the previous versions of it, but now it's using the NEC engine, the calculation engine on it. So that's why the name changed.
Anyway, say we've got a 20 meter dipole, and it's only about 60 feet away from us. And it was a monoband. So right here, this is where I would cut this coax, the 75 ohm stub. Ironically, I'm going to cut it at 75.8 feet. Now, what this is doing is this is giving us a high. Everybody looks over here and they go, oh man, that's no good. It's got a 2.2 swirls on it. This is because it thinks that there's a 50 ohm antenna, right? A dipole is not 50 ohms. If I change this, I think it's all going to fall flat, but I don't need to do that because I like doing it this way. I've got this high SWR on 20 meters right now, but if I feed that into my dipole, back at the shack, I'm going to land at 50 ohms. So I'm going to use my transmission line as a actual impedance transformer in this scenario. You can do this, guys. It's easy. It's so easy, and it's cheap. And if you do it wrong, throw it out. It's TV coax. It's like what? 10
I got
cents a foot?
500 feet of it at the Home Depot. Now, I didn't get the best 75 ohm coax, but I got 500 feet of it for $48. and that's crazy cheap. It's almost, you cut 100 feet of it, you're not happy with, throw it in the trash. I'm not suggesting you do that, but I'm saying it's ridiculously inexpensive.
So
RG6.
here's yeah. And so here's a 50 ohm dummy load on the end of some 75 ohm coax. And this is a real short piece because I wanted to do one harmonic for you guys. Here's the other end, and here's how I trim my 75 ohm.
Like an expert.
Yeah, you got to break it out. So instead of wasting time putting connectors and, you just stab it on top there. And we're going to go ahead and run this, right? Oh, wrong monitor. Where's my mouse, guys? There it is. And let's run it. And boom. So I actually cut it a little short. You can go ahead and laugh at me all you want. I was a little distracted. I cut it a little short. You see how it's actually just past the 10 meter band? But my SWR is still 1.2 and falling for the rest of the band. So at the end of this very short piece of cable is going to be a 50 ohm match for 10 meters. You follow?
Yeah, and you see your highs are a little above 2. That's about 2.2 SWR, which is what it was in SimNEC in the modeling software. So typically with that coax on a 50 ohm load, you're going to go between a 1 and a 2.2 SWR scale. Was it 2.25?
If you're trying to feed your dipole and you want a perfect 50 ohm match like I was able to achieve during the antenna challenge, you want to tune it for the high point, because what that means is that you have 75 ohms at the end of your feeder, not 50 ohms. So that's great. I think it's great. It's some wizardry. Anybody can cut and tune and make a dipole. Anybody. Absolutely anybody.
Not everybody can tune their coax.
Anyway.
No, awesome stuff, Zig. All right,
Here's
here we
a question
go.
for you.
Do you use 50 ohm connectors on? I did buy 75 ohm connectors, but when I screw them into my antenna, it's a 50 ohm connector, and the connector on the back of my tuner is also a 50 ohm connectors. So I'm going to say yes and no and maybe, and you just got to play around with it. We covered this slide. I want to go on to slide number 6, and we are not going to hit all our slides today, but that's okay. This is key parameters.
70, didn't you? Like 70
I have 20
slides or something?
I have 20. So anyhow, key parameters of transmission lines. So understanding key parameters ensures effective use of transmission lines in ham radio. Impedance matching, typically at 50 ohms, in Ziggy's case, 75. Prevents energy loss and reflections. Loss factors, including cable type and length, directly affect signal strength. Finally, the velocity factor determines the signal speed within the cable, impacting calculations for precise tuning and phase adjustments. Mastery of these parameters is essential for an efficient setup. And so basically what it's saying there is understand your cable, whatever it is, coax, open wire, balance line. Understand what it is, how it performs, do some measurements on it, model your antenna system, and then go ahead and set it up and play with it. When you do understand how all that stuff works and how you stir all those ingredients together to make the perfect secret sauce, you can do things like Ziggy does when you mess around with a non-standard coax cable like 75 ohms. What's interesting, in the olden days, everybody used 75 ohm cables because it was cheap, affordable, and extremely accessible.
You can get that anywhere.
Yeah, let's keep rolling. So I've got some practical considerations here for optimizing transmission line usage. So practical considerations are crucial when handling transmission lines. Choosing the right coaxial cable based on frequency and distance minimizes losses. I use RG8X for HF, and if I use that on 2 meters and 70 centimeters, I would be losing more than half of my signal. It's a 100-foot run. So you may want to take a look at line loss charts to understand how much you're actually losing with certain types of coaxial cable. I'm not advocating that everybody go out and buy LMR 400, 50-foot or 100-foot piece of it, because it's expensive. So you have to figure out how and what you want to do, and then what your budget will allow you to compromise. Keeping feed lines short can significantly improve performance, especially at higher frequencies. Lastly, maintaining high-quality connections by weatherproofing prevents ingress. which can degrade signal quality over time. So water can get into your connector and then into your coax, and it'll actually settle underneath of the shield. The shield is like that mesh on the outside of those wires, those coaxial terminations right there. These practices ensure longevity and efficiency in your setup. And Chuck, can you tell us a little bit about how you weatherproof your coaxial cable?
I use a self-amalgamating tape, which basically sticks to itself. It's different, and I wrap it with that, and then I wrap it with regular tape over the top of that. And then sometimes you can put like a little bit of conductive type grease or something in there. Some guys will just use Vaseline or something like that.
Yeah,
to
Uncle
help keep
Cal, man,
water out.
he goes out there with the Johnson and Johnson's Vaseline and gets that thing greased.
Yeah, and that'll
Like he's
keep
making
some
a
of the
big old
water out.
mess. But
But
he
the
does a great job.
self-amagnating's it's different. It has some
Well, it kind of turns into like one big giant piece of tape, right? Like it
Yeah,
adheres
it
to
kind of
itself.
sticks more so than regular tape, and it usually, like this is some right here, it comes off, and I think it has like a. It's been a while since I use it. It's got like, it has like a backing on it. Oh, sorry, I ripped that off, and then it sticks to
I'm
itself.
gonna get you on
So
the big
just-
screen, Chuck. There you go.
So there's this comes off the top of it. and
It's
then
like
you
a
wrap it.
2-ply.
Well, it's like the double sticky tape on both sides, basically. When you wrap that, then, but it's not good for. I don't think it'll hold up to UV. So then you take some good. I buy the 3Ms, the 3M 303, I think it is.
I don't know, but that's another thing. Like, I try to buy
Scotch, excuse me,
good
Scotch
electrical tape.
33
A lot of
plus.
people like, you shouldn't use electrical tape, but I buy Scotch or 3M because I've bought roll after roll after roll that like you can get like the Hamfest, you can get like the 10-pack of electrical tape for $3. It's not worth it. It's just not worth it, right? You put it on, it peel right off, it bubbles.
Home Depot 2-packs of this stuff, pretty reasonable. Usually they used to have
Yeah.
They used to have the 2-packs. I'll buy the 10 roll though for doing like when I go out, and sometimes I use it for making antennas and stuff. So,
Yeah,
and save
and,
save the good stuff for later.
Our lubrication expert, Hollywood, is telling us he would steer clear of petroleum grease as it melts under too low of a temp in the summer sun.
Yeah.
Especially if you wrap that thing out with black tape, I would imagine.
Yeah, there's special stuff for doing that kind of stuff. Special grease.
Our friend Ed Cozart, he's saying, do you black tape first and then self?
No, the self amalgamating, I think they call it, because it's not UV resistant from what I understand, and so in basic you're sealing your coax twice. Like on my tower, it's got the first one I just showed you, and then it's got regular tape over the top of that.
He says, try disc brake high temp ceramic grease.
Yeah.
I'm terrible, man. I'm terrible about weatherproofing. I hit it with a little electric tape and I'm done. Most of the time when I put an antenna up, I'm like, oh, this is only very short-term temporary.
Right.
Then it ends up staying up forever. And
Oh,
then
I
I end up
never-
having, like at one time I was holding my coaxial and water was coming out. And the BNC was completely rusted and everything on it. And I was like, well, you only live once. What am I going to
My
do?
Elmer came over and we did a ham raising, which was crazy because I had like 20 people I didn't know all at my house at like 8 a.m. one day to help me put up my 40-foot antenna. And yeah, that's what they called it. And so my Elmer's right there at the antenna, and he's about to do, land the antenna with the coax. And it was like so surreal. He pulled out the smallest little jar of petroleum jelly you'd ever seen out of his flipping pocket, and he takes a big old 2-finger scoop and slaps that thing right inside of the PL connector and then jams that up in there. And I was like, oh,
Got to grease it, boy.
yeah, just
Gotta get
fill
that
it full of
grease.
grease. Just fill it full of grease. It's been up there for 3 years now. Granted, it has slowly gotten longer. I don't know how. We went from 147 to 144 megahertz, but that's just how antennas degrade.
It's that grease. So let's talk a little bit about proper matching. And we've kind of been building up to that. So standing wave ratio, and I've got videos going into SWR in depth. I'm actually working on a new one. So we're only going to hit it at a high level. So I don't want all the SWR police to get upset with me.
I do.
SWR is a crucial metric in ensuring efficient antenna system performance. High SWR indicates power is reflected rather than transmitted. So when you're squirting the watts down your coaxial cable towards your antenna, three things can happen to that power. One, it can be reflected. Two, it can be radiated. And three, it can be absorbed as ohmic resistance and turned into heat. Obviously, we want the most of it reflected. When we have high SWR, we're messing with our power transfer from our source to load, source being the transmitter, load being the antenna. You want to push as much of your power as possible towards your antenna, and then hopefully the most of that power is radiated, not absorbed or reflected. So when it's reflected, it reduces efficiency or risks transmitter damage. Most modern transceivers do have SWR protections in them where they'll actually fold back and won't keep putting out that power level to prohibit damage. But older radios and tube amps and stuff like that can get damaged from high SWR easily. Achieving low SWR optimizes power transfer, preserving energy for effective communication. Proper matching techniques are not only essential for system protection, but also significantly enhance overall performance. Questions, comments?
All the videos I see where the swears don't matter. It just
My
bounces
swears.
around.
Swears.
Yeah,
My swears.
it just bounces around and it still radiates.
Yeah, there's a lot of hogwash out there on that one. But what are you going to do? So a lot of times we use things called matching devices. And matching devices play a pivotal role in bridging impedance gaps within antenna systems. Balun and ununs facilitate seamless transitions between antenna types and feed lines, addressing mismatch challenges. Antenna tuners, whether internal or external, adjust the system to appear perfectly matched for the transmitter. Not only safeguards the equipment, but it optimizes signal strength and system reliability. So I use a lot of antennas that are not resonant. And shame on me for that. Like the Cartena Poseidon would be one, and the Cartena Aries, a 9-to-1, it would be one of those.
I'm just as guilty. I'm a super random fan, and it gets
Yeah,
the most
and
new
I
hands on the air. You know.
And I use an antenna tuner manual, of course, because I'm an alpha ham. And what I can do is I can tune a 1-to-1 from my radio's perspective. On the other end of my tuner, I have what's called a conjugate match, which is a mirror reflection of the impedance at the antenna feed point. And then whatever SWR I have, it gets reflected and then re-reflected back and forth until it goes out into the antenna via radiation or heat. I do lose power with each reflection because I do have RG8X, which is pretty good coaxial cable, but it does have loss. Oh, here we go. Prep Ham Paul talking smack. That's
Hey,
right,
buddy.
son. Alpha ham.
I use 8X for most of my portable
do
stuff
too.
I could do. It's easy.
I used to be able to get 100 feet of 8X for around $60. It's around $99 now because of the chip shortage, I guess. I don't know.
I've got 100 feet of 8X, and I thought the loss was going to be crazy, but no, not in
portable
the
too.
HF.
I mean, shoot.
Yeah, not in the HF spectrum, but
But we use mostly ununs, like a 4-to-1 or a 9-to-1, 49-to-1, in a lot of our antennas, and that's because of where we feed those antennas, or because we're choosing to use random wires and the impedance is super duper high. By putting it out there, what you really are using is like a static tuner, some people call it a matchbox, to adjust that impedance. Typically need a tuner at the radio end or at the antenna end if you're one of those types. To continue to bring that down, but the Baluns and the ununs do much of the heavy lifting. It looks like our buddy Brent and 4BDW. How you doing, man? He uses a manual tuner as well.
Can't get any
And our
better
friend
than that,
Maker Mikey, he's saying conjugate match sounds like something in prison. Well, maybe
Yeah, I was going to ask you if that's something you learned on one of your stints in the prison there. I didn't know.
No.
I kind of got the same thing when you said that.
I think you're congenital. What was it called? It's a different match that you get with it. What you're talking about. We'll keep on rolling here. We got 12 minutes left. So I talk a little bit about the ionosphere and its layers, because we are talking antennas, transmission lines. So why not talk about the ionosphere? It does play a pivotal role in HF propagation by refracting signals back to Earth. The D layer is at the lowest altitude, and what that does is it primarily absorbs lower frequencies during the day, during daylight. The E layer offers sporadic reflection. So you hear a lot of people talk about tropospheric ducting, I believe. That is not sporadic E. Sporadic E is at that E layer, so it goes D, E, F1, F2. At night, the D layer disappears very quickly after sunset, and the F layers collapse into a single. So you don't have F1 and F2 anymore. You just have a single F layer. The F layer is the one that does the primary heavy lifting when we talk about skywave propagation. During the day, though, the D layer is what wreaks havoc on us. So a lot of times you hear people say, "Oh, well, 40 is not open." That is because the D layer is absorbing those signals. And what you can do is you can look at propagation reports, and you can see that based off the propagation reports, what you're left is your lowest usable frequency. The higher up you go in frequency, you hit a certain level where the frequency just goes straight through the ionosphere, won't refract down. That is called your MUF, your maximum usable frequency. If your maximum usable frequency is lower than your lowest usable frequency, skywave propagation is impossible. And that's what happens when we have geomagnetic solar storms. I'm going to keep on trucking here.
Yeah.
Here you can see the different layers. And this is slide number 11. So I want to talk a little bit about the types of propagation. And we rely on multiple propagation modes to connect over varying distances. Ground wave propagation provides dependable regional coverage at low frequencies. And it works better at like 160, 80, 40. And think about AM radio as ground wave propagation. Vertical antenna traverses across the ground, goes for a certain distance before it's completely attenuated and you can't hear it anymore. Skywave propagation leverages ionospheric refraction for intercontinental contacts, or what we would call DX. Rare modes like sporadic E and tropospheric ducting and meteor scatter are less predictable, but they enable unique, sometimes extraordinary communication opportunities. In this particular diagram that I have on the slide, what I was showing is what is takeoff angle of your frequency, your incident frequency, and the more obtuse that refraction angle is based off of your takeoff angle, the further it goes, right? So the yellow goes further because it has a lower takeoff angle. That's the angle coming off of the ground. And then the angle refracting off of the F layers is more obtuse. And that gives you a wider angle and further communications are possible there. I did use this one in a recent video, Interstellar Starman. I like to reuse I like to plagiarize myself.
We got to get him on stream.
So we had some influencing factors here. So propagation conditions are shaped by several dynamic factors. Solar activity is measured by sunspot numbers and the solar flux index. This determines how ionospheric layers, I have trouble saying that word, support long-distance communications. During daylight hours, they enhance higher HF bands, while nighttime fosters propagation on lower bands. Seasonal variations also impact ionization, influencing propagation quality. Understanding these factors allows operators to adapt strategies effectively. So some folks might have a daytime antenna and a nighttime antenna. Maybe during the day they're doing 20, 15, 10. Maybe nighttime folks are doing 40, 60, 80, 160. I don't know. I don't personally know anybody who operates regularly on 160, but those people are out there somewhere.
I have in the past. I used my my 40-meter half wave to do it. I just tuned it, and it works surprisingly well. So
I think he got ran off 80 meters. Is that what did that happen to you recently?
Yeah, he's scared to go back. He said.
I just remembered why I don't do that anymore, because it's just late nights and arguments. It's pointless.
Right about everything, right?
Absolutely. Yeah. I said hi to some friends that I normally talk to, and there were some other guys in there, and I was talking about the antenna challenge, and I was talking about the 160-foot stub that I was feeding my my dipole with, and oh my, did I hit a nerve?
All right. You can't use 75.
Oh, yeah. He said, you can't run power. Bro. You can't run power. You can't run power in that.
And you were like, my antenna's so good, I don't need to run power, son. Now what?
Yeah,
Well,
he's
you're only
over
running
there.
100 watts, right?
I don't have an amplifier. He's the guy with the big amplifier.
You might want to go to RG11 for that.
I might have to step it down.
Well, it's like if you buy a Corvette, right? You'd be like, you can't tow a camper with that, boy.
It totally reminded me. I was like, you know what? I've done POTA for the first time. I had a blast. Maybe I'm just going to be a high bander for a little while.
I
Let
hear
these
you,
seven,
TJS.
let
Thank
these
you, thank you for the
Thanks.
super chat, bro.
let these 75, 80 guys, fall off a little bit.
Yeah. You just got to
We're
find
gonna-
the right group of guys.
We're jumping ahead to slide.
That's exactly
14.
what it is.
'Cause we're running out of time here, and I have slide 14. Antenna height and placement dramatically influences performance. Elevating angles improves takeoff angles, essential for long distance contacts, and we just talked about that. Careful positioning avoids signal degradation caused by nearby obstacles like metal, dense foliage, and carbon fiber mass. I'm just kidding. I just added that in on the fly. For operators in urban or HOA restricted areas, stealth installation strategies offer a practical way to balance discretion with efficiency. And I would tell you, check out HOA Ham. That guy's awesome, Bob. We probably need to have him back on the Coffee and Ham radios.
Is he the
And,
closet chat guy?
Yeah, he's in the closet when he's operating.
It's pretty impressive, actually.
He has gotten everything in there. He's like so uptight. It's the way I'll describe him about his layout, and everything has to be perfectly aligned and in its place. He would faint if he saw this mess I got here.
He would faint if he saw my.
But he is super creative when it comes to stealth installations. He's just a master at it. Really enjoy his stuff. And Ed is agreeing with me. And Chuck, you with us still over there? Did you fall asleep?
I
What's
am.
going
My
on?
buddy's texting me here. He's
I just
pretty-
wanna make-
he's doing something for me, so I was getting back to him. Sorry.
No, I just want to make
guess.
sure you're still among the living.
I am.
Let's go on. We talked
15?
about weatherproofing and stuff already, so I'm just going to keep rolling. Cable handling. You got to be careful when you handle that cable, son. Proper cable handling is essential for maintaining system performance, keeping coaxial cables away from potential interference sources like electrical wiring, metal structures, preserve signal quality. Supporting cables with appropriate ties and mounts prevents physical stress, reducing the risk of damage. Stress relief is super duper important with antennas and coaxial cable. Regular inspection ensures cables remain intact and reliable, contributing to consistent transmission efficiency. And that's when I had to go out and let the water drain out of mine because I had not been doing proper care and feeding of my coaxial cable.
Shame on you, man.
I know,
I got a
embarrassment.
piece that just sits out there all the time, and I use it.
Embarrassment to the hobby.
Up in the last couple of years, we haven't had much rain, so it didn't really matter.
Well, I got to tell you, so this time of year, we have all the Christmas lights everywhere, and so do all my neighbors. And depending upon the antenna that I'm using, I can turn people's Christmas lights off. And
Yes, dude.
I've done it to my own plenty. And then I changed my antenna, and then I was turning the neighbors off and stuff like that. So I got to really be careful about nighttime operations around here.
You going
I've
for the
messed
Worked
with the
All
wife's-
Neighbors Award?
Yeah.
Right.
I've messed
Well, if
with the
anybody
wife's
calls, I'm
hairdryer
like-
before.
Yeah, the hairdryer, I've
Oh,
turned that
yeah.
off, reset GFI outlets.
Mm-hmm.
But if anybody calls and be like, my lights just went, I'd be like, the damnedest thing, it just happened to me too. I don't, it must be the drones.
You
My
know,
buddy-
2 meters online with a lot of that stuff. If
My
you're,
buddy-
if you're shooting.
My buddy that's got an amplifier that I'll not get into specifics about. Not only did he fry his neighbor's gate opener, but he fried just about everything inside of his house. So
Wow.
our RF is not a joke, people. Not a joke. It was kind of a costly mistake on his part. He made good with the neighbors.
Well, again, I want to be respectful of other people streaming tonight, so we're just going to hit our last slide. So I'm going to say, to conclude, we've explored how antennas, feed lines, and propagation directly shape your ham radio experience. Remember, the beauty of amateur radio lies in experimentation. Start small, learn by doing, and continually refine your skills. Let's now address any questions, if you have any, but we only have 1 minute.
I would just say put the best antenna up you can do, and then worry about your radio.
Yeah, get up what you got, and then
Yeah.
and then improve incrementally from there. Thumb.
Hey, Thump's here.
He just made it.
Just
I was
for the
talking to
end.
him earlier. He's like, "You normally don't stream." I was like, "I know. That's why I told you, bro." So,
That's why you
anyhow,
warned
with
him.
that, I think I'm going to hit the end button, and I want to say thank you to everybody for watching. Thanks to my friends for being here, helping me get through this show tonight, and
Yeah,
thanks to
it's fun,
everybody
man.
who contributed via Super Chat. It's greatly appreciated. Talk to you all later, and thank
Later,
you very
everybody.
much.
Thanks, guys.